Motion is intro
वो करके क्या जो कर कर हाँ वही करना है क्या है सिंपल and now we do that line verification अरे एडिशन कौन सा तू नीचे वाला यही ना
production. Motion is common to everything in the universe. We walk, run, and ride a bicycle. We see leaves falling from trees and water flowing down a dam. Automobiles and planes carry people from one place to the other. The earth rotates once every 24 hours and revolves around the sun once a year. The sun itself is in motion in the Milky Way, which is again moving within its local group of galaxies. Objectives. At the end of this lesson, you'll be able to understand mechanics and its classification, distinguish between statics and kinematics, distinguish between rest and motion, understand relative motion, understand types of motion, define point mass object and frame of reference, differentiate between path length and displacement, difference between speed and velocity. Mechanics and its classification. All living things move by themselves without any external help. Animals move from one place to another, or they move their body parts, are all motion. The branch of physics which deals with the study of motion of material objects is called mechanics. Mechanics is broadly classified as 1. Statics, 2. Kinematics. Statics and kinematics. Statics. The branch of mechanics which deals with the study of objects at rest is called statics. It is the study of motion of objects under the effect of forces in equilibrium. Time factor plays an important role. Kinematics. The branch of mechanics which deals with the study of motion of objects and the factors which causes motion. The force is the cause of motion. Time factor plays an important role. Rest and motion. Rest. An object is said to be at rest if it does not position with time and with respect to its surroundings. When the book lies on the table or a person sitting in a chair shows rest. Motion. An object is said to be in motion if it changes its position with time with respect to its surroundings. A bird flying in air, a ship sailing on water are examples for a body in motion. Rest and motion are relative. A person sitting in a moving train is at rest with respect to his fellow passengers, but is in motion with respect to the objects outside the train. This is the situation when object in one situation can be rest, but in another situation the same object is in motion. Hence, rest and motion are relative to each other. Example: a person sitting in his house is at rest, but with respect to Earth, it is in motion with respect to other planets. Types of motion. Motion is of three types. 1. Rectilinear motion. When body is moving along a straight line, is called rectilinear motion. 2. Circular motion. When body is moving on a circle, it is called circular motion. 3. Oscillatory motion. The to and fro motion repeatedly about a fixed point in definite time interval of time is called oscillatory motion. Point mass object. Object is a point mass object if during motion in a given time it covers distances much greater than its size. Example: the revolution of Earth around the Sun. The diameter of Earth being very small as compared to the length of the orbit around the Sun, the Earth can be regarded as the point object. Frame of reference. The system of coordinates axes, three straight lines inclined to each other at right angle, attached to an observer origin with respect to which the observer can describe position, displacement, velocity, acceleration, etc. of a moving object. It consists of three coordinates, x, y, and z with origin O at the starting point of the particle. Motion in 1, 2, and 3 dimensions. One-dimensional motion. The motion only in one out of three coordinates specify the position of the object changing with respect to time. Example: car traveling in a straight line. Two-dimensional motion. The motion of an object in 2 out of 3 coordinates specifying the position of object change with respect to time. Example: a billiard ball moving over a billiard table. Three-dimensional motion. The motion of the object when all the 3 coordinates are specified, the position of the object change with respect to time. Example: a kite flying on a windy day. Difference between path length and displacement. Path length. The total path length is the actual distance traveled by the object in a given time during motion. It cannot be zero. It is a scalar quantity. Displacement. The shortest distance between the two positions of the object in a particular direction during that time is called displacement. It can be zero. It is a vector quantity. Speed of an object is defined as the ratio of the total path length covered and the time taken by the object. Therefore, speed is equal to path length upon time interval. It is scalar quantity. SI unit is ms raised to the power minus 1. Dimensional formula: m raised to the power 0, L raised to the power 1, T raised to the power minus. Average speed and instantaneous speed. Average speed: the ratio of total distance traveled by the object to the time taken. Therefore, average speed is equal to total path length upon total time interval. Instantaneous speed: the speed of an object at a given instant of time is called instantaneous speed. Velocity and its types. Velocity. Velocity is defined as the ratio of displacement to the time interval taken by the object. Therefore, velocity is equal to displacement upon time interval. It is a vector quantity. SI unit is m upon s. Dimensional formula is equal to m raised to the power 0, L raised to the power 1, T raised to the power minus 1. Uniform velocity. When object covers equal distance in equal interval of time is called uniform velocity. Non-uniform velocity. When object covers equal distance in unequal interval of time or vice versa, it is called non-uniform velocity. Graphical representation of motion. Distance time graph. The distance time graph gives us the speed. The slope of a distance time graph gives speed. If the distance time graph is a straight line, the speed is uniform. If the distance time graph is a curved line, the speed is non-uniform. Did you know? Motion in the universe is described through two sets of apparently contradictory laws of mechanics. Motions of all large-scale and familiar objects in the universe, such as projectiles, planets, cells, and humans, are described by classical mechanics. The motion of very
Okay, so I think you understood the basics of straight line, motion in straight line. Are you able to hear me, everyone? Okay, fine. So now I'll be showing you the technical thing. What are asked in your examination, you have to quickly write down in your note and understand it. If you have any doubt, you can ask me. Fine. So we'll start with a chapter that is motion in straight line. Introduction. Motion in straight line. Look at this car. This car is moving in a straight line. We have many more examples. What is a particle? So first thing you should know, what is the meaning of particle? A particle is an object which has a negligible dimension. Okay, you cannot measure the dimension. It is a point, maybe it is a stone, okay, something like that. Okay, next, what is a rigid body? Rigid body, it is a combination of particles, and when an external force is applied, there will be no change in its dimension. Rigid means a body which will not change its shape. Okay, for example, you have a stone, that is a rigid body. Next, are you a particle or a rigid body? Are you a particle or a rigid? Tell me, are you a particle or a rigid body? Just a minute. Yeah. So now imagine, as relative distance is less, you are considered to be a body. So imagine here down you have two kids. As the distance between them, it is getting lesser and lesser, they find themselves as a body. But if they are very far, we call them as a particle. Now imagine there is an aeroplane and it's flying in air, and this is Earth, and now here I am on Earth. You can see a kid looking towards that aeroplane. So if I see this kid from aeroplane, it looks like a particle. Okay, imagine you are in aeroplane and you are looking down, there is a boy in on Earth, so that boy will look like a particle. Okay, so as relative distance is large, person appears as a particle. Got it? Next, particle and rigid body are relative terms. They are all relative terms. So first let us try to understand what is rest and what is motion. First, what is rest? This TV is at rest. This fan is at rest. If a body does not change its position with respect to its surrounding, then the body is said to be at rest. So here you can see on the slide, TV and fan, they are not moving, they are as it is in their own place. So I call these objects at rest. Got it? Next, what is motion? Now imagine I gave you an example of fan that was at rest, but now you can see the blades of this fan is in motion. So moving blades of a fan, a car is moving on the road. Okay, so these objects are moving, so these objects I call it in motion. A moving car changes the position with respect to its time. So whichever object changes its position with respect to time, I call it as the object is in motion. So are the passengers in the bus at rest or in motion? So this is a concept asked in an examination. So try to understand this into, in a deeper conscience. For example, you are standing in the bus stand, and here you have a bus which is approaching this bus stand. Okay, so first let us try to take a case study. Okay, imagine a bus is crossing a bus stand, and on in bus stand there are many passengers waiting. So let us take passengers in the bus are at rest relative to each other. Look at this now. This is a bus. Inside the bus, you can see some passengers. So if you check, are these passengers moving? Are these passengers moving? That is a question. So the passengers are not moving, only the bus is moving. So if I consider the passengers only, the passengers is at rest. So this is called as the relative motion. Now let us take the other case. Passengers in the bus are in motion relative to people at the bus stop. Now I am comparing, this is the bus stop, and now this is the bus, and now the bus is moving. Suppose now if I ask you a question that comparing the bus, people standing in the bus stand and the people those who are inside the bus. I'm comparing these two people. Okay, I'm comparing these two people. So now what is the answer? The passengers, are they at rest or are they moving? So now the answer will be they are moving, they are at motion. So it all depends on your relative position. I'm going to compare. Okay, whatever objects I'm going to take A and B, I'm going to compare and just check whether they are in motion. Got it? Next, what is rest? A body is said to be at rest when there is no change of position with respect is the bus, and the bus is moving in a particular direction. Okay, so now here